Efficient improvement in bandwidth using rectangular microstrip patch antenna, and our objective is to enhance the bandwidth and to suppress the harmonic. It was done by introducing slot at the ground structure which provides good impedance matching. For attaining better bandwidth, the substrate is the important thing. RTDurite5870 is the substrate used here. We introduce slots as the ground structure, as I said, to improve the overall bandwidth and width of the slot, which directly controls the bandwidth, and optimized parameters have set as 0.2 mm. Finally, a prototype antenna operating at 4.65 GHz to 5.10 GHz is designed and fabricated. The measured results shows that the bandwidth is increased. The measured result shows that the bandwidth is increased up to 150 MHz than that of the traditional patch antenna. And coming to the introduction about microstrip antenna, it is the type of an antenna that consists of a radiating patch on one side of the dielectric and a ground plane on the other side. It offers an attractive solution to compact and low-cost design of modern wireless communication system. It has an advantages of lightweight and low volume, low profile planar configuration which can be easily made. It has a drawback of narrow bandwidth gain and surface wave excitation that reduce radiation efficiency. So to overcome that, several techniques have been implemented. And the literature survey, first paper is the compact filtering antenna using CRLH resonator and defected ground structure. In this paper, a compact filtering antenna with high H gain selectivity using a composite right or left-handed CRLH resonator and a defected ground structure which achieves a twice wider bandwidth. Next one is a single layer wideband U-slot microstrip patch antenna array. In this paper, the U-slot microstrip patch antenna array in single layer helps to form array easily and increase the bandwidth from 18% ranging from 5.65 GHz to 6.78 GHz. And the explanation of our project is it presents a new compact couple-fed patch antenna in a single layer substrate. By using a pair of lambda by 4 resonator, the bandwidth of the antenna is significantly enlarged, while other advantages of the antenna such as low cost, low profile and easy integration still remain. In the analysis, an equivalent circuit model is proposed to analyze and design this proposed antenna. The good performance is demonstrated by comparison with the traditional insert-fed patch antenna. The measure and simulation result shows that the bandwidth has been enlarged by 150 MHz. The slot is introduced in the ground structure which increases the bandwidth considerably by 600 MHz. This is the output structure of our traditional antenna, in which this is a T-shaped structure. This is the table specification, and this shows the result which is obtained at 0 GHz, which shows that the radiation pattern is good and the harmonic is present in the traditional antenna. This is the radiation pattern of our traditional patch antenna, which the color represents the maximum gain which is in the front part of the antenna, so the bandwidth will be good. This is the polar plot of our traditional antenna which gives a clear representation at 4.9 GHz. This is the modified traditional antenna in which the patch and the resonator is separated. By increasing the gap between these, the bandwidth will be increased, and this shows the specification of that modified traditional antenna and the result which is shown. And the first is the S parameter which is obtained at 4.9 GHz and the harmonic was reduced. This gives the clear representation of the polar plot and the radiation pattern as I said in the traditional antenna. This is our proposed antenna in which the slot is introduced at the ground structure. The comparison of a modified proposed antenna and the proposed antenna, the result shows the comparison of that, in which the bandwidth is enhanced up to 150 MHz. And the conclusion is we have implemented the proposed antenna which has a bandwidth of 600 MHz, which is 150 MHz higher, as I said. This will cover the overall performance of the antenna. Thank you.